Ian Hubert is an incredibly talented 3D artist that many of us are familiar with. Now recently, Ian shared a technique called delighting, and it blew my mind. To show you what delighting can do, let's add some VFX to this shot. So here in Blender, I've recreated our camera movement and the objects in this footage, and now I'll go into render view and I'll just add in my VFX elements, and boom, they're just integrated into the footage with zero compositing, which works because I'm using the delighting technique. So today I'll explain what delighting is and how it works, and then we'll dive into Ian's new delighting plugin called Compify.
When you want it looking right, use the magic of delight, 'cause it just might change your life. So you
got to delight. To follow along with this video, you can download all the files for these VFX shots for free. Just click the link below. Okay, to start, what is delighting? Delighting is a technique most often associated with photogrammetry, which is when you take multiple photos of an object and use the program to turn those photos into a 3D model. Now, as you can see, the material on this model shows the highlights and shadows from the environment we took the photos in. Delighting is the process of removing this lighting information, taking away the shadows and changes in brightness, and giving us a neutral base color for the model. Now that this model is delit, it can be used in a different scene and properly relit with different lighting. Now, Ian Hubert applied this delighting concept in a slightly different and unique way. To see how it works, let's transform this shot into this. Now, there are some common steps I'd follow for any VFX shot like this. First, I'd do camera tracking and camera layout. This will give me a virtual camera that moves in the same way as my real camera and is oriented intuitively in 3D space. The next step is scene reconstruction, which consists of modeling the different objects in this environment and positioning them so they align with the footage. We'll call this the footage geometry, and having this footage geometry in place makes it more intuitive to position the other VFX elements. Following this is lighting. We want to recreate the lighting of this footage, and to do this, I created a 360 HDRI at the same location I was filming in, which casts light onto this 3D scene and perfectly recreates the lighting. This takes us from this, no lights, to this, what we'll call the footage lighting. The next step is texturing, and this is where delighting is going to be a game changer. In this step, we want to give our footage geometry a material that's not white like this, but instead looks like the concrete and other things in the footage. To do this, we're going to take the footage and actually project it onto these surfaces, thus using the footage as a material. This takes our render from this to this. As you can see, we're missing our shadows and we're not seeing any light from this glowing sphere. To understand why this is happening, you need to know that there are only two types of materials when we work in a 3D program. There are light emitting materials and light receiving materials. By default, our footage is being used as a light emitting material. These types of materials can only emit light and they can't receive light or shadows. If we use the footage as a light receiving material, the surfaces look like this, which is super dark, so let's lighten this up so we can see what's going on here. Light receiving materials cannot emit light, and they only receive light and shadows. Now, we like this light emitting material because it looks exactly like our original footage, whereas this light receiving material just looks a bit off. Remember, it's actually this dark. But the emitting material can't receive light or shadows, and this is a major deal breaker. So we're going to go forward with this receiving material, and we'll focus on solving this third issue so that the material looks more like this and better matches the original footage. But again, our problem is that when we use this footage as a receiving material and it's lit by the footage lighting, it looks like this, whereas we want it to look exactly like the original footage. And to reiterate, our footage lighting is fine. It's just our footage when used as a material that's not looking correct. Now, this is where Ian, along with his genius friend Nathan, figured something out. They saw this whole thing as a math equation and realized that if there was some way we could divide the footage by the footage lighting, these terms would cancel out and the equation would work. But how do we even go about dividing out lighting? Well, here's what these guys figured out. If we change the footage geometry back to a white material and take out these VFX elements, The RGB pixel values of this image are simply a measure of how much light from the footage lighting is hitting each point on these surfaces. So we'll call this our footage lighting measurement image, and it will take the place of this term in the equation. And then all we have to do is divide the pixel values of these two images, and this will essentially remove the footage lighting from the footage. We then use this as the new surface material, and now when this is lit by the footage lighting, it looks exactly like the original footage. And now, the coolest part of having all this set up is that I can add my VFX elements right in my 3D viewport, and it just works with zero compositing. Now, once you try this out, you'll see. It's just so fun and freeing to be able to build and visualize your VFX shots right in the viewport without having to wait for rendering and compositing. And so here's the full render with no compositing at all, and then I added some glow and color grading to complete the shot. The most important thing to understand is that this step, where we divide the footage by the footage lighting, is what makes our light receiving material appear correctly. And that's because this division is delighting our footage. Just like how we did with the box, turning the photos into a 3D model, we're doing the same thing here, turning our footage into a 3D scene. And just like how we removed the shadows and highlights from the box, well, this is the same idea, going from the lit original footage to delit footage where the shadows and highlights are removed, resulting in a neutral base color. And just how we took that delit box and put it into a new scene with new lighting, once our footage is delit, we can completely change the lighting of our scene. For example, here I'm playing with a different take on this same scene, and to make this moody, I can just turn the footage lighting off and add my own lights and finish this with some volumetric fog, and there you go. We've got a completely different look, all right in the viewport with no compositing. Now, for everyone out there who loves compositing, me included, you can still use this workflow and create all the render layers and render passes you might want for compositing. I'll address this in a bit. Now, one great thing about the delighting technique is that it's pretty forgiving. For starters, you don't need to perfectly recreate the footage lighting. To illustrate this, I'm going to totally mess up the lighting in this scene, and when we take this and divide it by the footage, this clearly doesn't look correct. But then when we go into rendered view, we actually see our footage just like we wanted to. And that's because in this equation, any footage lighting, even if it's bad footage lighting, will always cancel out. Now when we add our VFX elements, they're going to be lit by this inaccurate lighting, and this doesn't look very good. So the more accurate your lighting, the better these VFX elements will integrate into the scene. But again, your lighting doesn't need to be perfect. You also don't need to have perfect geometry in your scene. For example, in this shot, these plants over here would be pretty hard to recreate in 3D. So I just put a simple piece of geometry here, and that works pretty well to catch the lighting. In summary, you can benefit from delighting even if your scene isn't set up perfectly. So let's finally talk about how to set up delighting in Blender. And remember, before we delight, we need to start with these steps. Also, as always, we want to have good color management throughout this whole workflow. This allows me to use this log footage in the proper way to get the most accurate and consistent image data throughout the workflow. These are all fundamental steps for any VFX shot, which unfortunately I don't have time to get into today. But I'm very excited to announce that I've been working really hard on a VFX course, which will teach you all these fundamentals and more. And on October 1st, I'll be launching a Kickstarter for the course. Here, check out this trailer. It's one thing to walk around with the camera and imagine all the things you could put in the world around you. It's another thing to know you have the skills to bring those visions to life. This isn't about how to make one VFX shot. It's about making anything you can think of. So this equipment will help us recreate our scene perfectly in 3D. But check out the control this gives us in compositing. Because this is set up right, we can just drag anything in and it works. You're gonna develop the fundamentals to get consistent results. So come on, let's make the work you've always dreamed of. I'm starting an email newsletter that will provide updates about the course and the Kickstarter. You can subscribe to that at the link below to make sure you don't miss out. Okay, back to our setup with these steps finished. Now, Nathan created a Blender plugin for Ian called Compify, which makes these next steps quite a bit easier. So if you're a Blender user, definitely go download and install the Compify plugin. But as we go, I'm going to show you how to do a lot of this setup from scratch so you can have a better understanding of what the Compify plugin is doing. So we'll pick up with this material step where we want to change the material on this geometry to look like the footage. Let's start by projecting our footage onto our geometry. To do this, we'll create a new material. I'll delete this default shader. Then I'll hit Shift A, go to Texture, Image Sequence, and I'll import the image sequence of my footage and then hook this up to the material output. Then I'll select the rest of the footage geometry and copy this material over to them. Now, as you can see, this footage is not being mapped properly onto this geometry. To fix this, Ian's Compify add-on comes with a really nice feature where we can select our camera, go into the Object Data tab, and we can click this button, New Camera Project Node Group. If we come back to our projection material, this button has created a new node group that we can add here and plug into the vector input. This node group projects UV maps from the camera's perspective onto this geometry, and we should see the footage now projected accurately. Now let's add our VFX elements to this scene. And in this render view, we see we're missing our shadows and light coming from this ball. Again, this material is currently a light emitting material. To make this a little bit more clear, this setup is the same thing as creating an emission shader and using our footage as the color input. To turn this into a light receiving material, we'll create a diffuse shader and use this instead. And again, this looks too dark, but I know the lighting in my scene is fine, so this darkness is a problem with this material. To fix this, we need to delight the footage, and to do this, we need to create the footage lighting measurement image. Let's remove this color input from the diffuse shader so that everything has a plain white material again. Also make sure the color of the shader is pure white with a value of 1. Then I'll turn off the VFX elements. Now this actually isn't the best representation of the lighting on these surfaces. You see, our current setup looks like this. A light source emits a light ray that bounces off these white surfaces and into the camera. But instead of this light source, we can actually use our footage as a light emitting material to get an exact representation of the light leaving this point. But then right at this point before the light ray enters the camera, we want the surface to be white to get a pure measurement of the amount of light hitting this point. In other words, we want the surface to be two different materials at the same time. Ray tracing render engines like Blender Cycles will label the different segments of a single light ray's path based on various properties. Segments that bounce directly into the camera are labeled camera light rays. I can use this label and set everything up so this surface initially has this material, which emits light, and then right before the light ray hits the surface and goes into the camera, the engine can switch to the white material and then finish that light ray's path. So if we have many light rays like this, all the camera sees is the white material, while behind the scenes, the initial ray segments are all being emitted from the footage material, and there are still other light rays being contributed from the footage lighting as well. Hopefully that made sense, but if not, just do this. In our material, we'll create a mix shader, and we'll put the white diffuse material in the bottom and the emission material in the top. Then we'll create a light path node, and we'll plug the isCameraRay output into the factor slot. So with this mix shader, we're saying that every light ray should use this emission shader, but if the light ray is going into the camera, it should use the white diffuse shader, which when combined looks like this. And this is our footage lighting measurement image. And again, we want to divide the footage by this image. So let's add a color mix node and we'll set the blending mode to the divide operation. And then we'll put the footage in the top and the light measurement image in the bottom. But we'll notice we get this red connection, and that's because it's not possible to use a shader like this. You see, the output of any shader is being calculated continuously by the render engine, and so it's not fixed image data that we can use in this way. In order to use it, we need to freeze or bake this shader data into an image. So let's create a new image texture node and hit New Image. We can name this Light Bake. I'll make the resolution 4096 by 4096. Make sure to check 32-bit float and hit New Image. This will be used to store the baked image data of this shader. Now let's open an extra window and go to the UV editor, and then at the top we can choose to open this new image we just created. Next, we want to UV unwrap all our objects, so let's select all the footage objects, and it can be helpful to apply the scale of all these objects to make sure they're proportioned correctly in the UV map. Then hit Tab to go into edit mode, hit U to unwrap, and choose Smart UV Project. We'll add a very small island margin of 0.003. Then if we hit OK, this will unwrap all these objects together and fit them into this square image. Then we can hit Tab to go back into object mode. If we click an object and go into the Object Properties tab, under this UV Maps dropdown, we can see any UV maps associated with the object. If there are multiple UV maps on a single object, this camera icon determines the active UV map that we just unwrapped into. It's very important to make sure that all your objects have the same active UV map selected. If they don't, it can be pretty time consuming to go to each object and change the UV map settings. So you can get this Batch UV Tools add-on, which is free on Gumroad and makes managing multiple UVs a lot easier. But the Compify plugin also automates this process, which I'll show you very soon. Okay, next we'll add a UV map input to this image and select the UV map we just created. Now let's go into the Render Properties tab, which is where we'll find all the bake settings. We can use these default settings for most of this. Our target is going to be this image texture, and we'll set the margin to be 4 pixels. Before we hit bake, we want to make sure we turn off any extra objects or lights that do not represent the original scene. Also in our material, make sure this shader is still connected to the output, and then we just want to click on the image texture node to indicate that this is where we want the baked data to be stored. We then need to select all the objects we want to bake, and finally we can hit bake, which will bake this shader for all these selected objects. By the way, the baking process will use these render settings, and I find that a noise threshold of 0.5 is good for this scene. Also, if we are using the combined bake type, our baked image will be denoised if we have this denoised setting selected. But I recommend keeping this off since it can lead to some weird artifacts. Instead, once the baking is finished, let's save this image as an EXR file with these settings. I will then go into the Compositor tab, select Use Nodes, add an image input node, open the light bake image, Control Shift and click to create a viewer node and hit backdrop. Then I'll add a denoise node that will denoise this image. Then with the viewer node selected, in the right panel, select Save this image and save out this new denoised EXR file. Then back in the Layout tab for the material, we will switch out the noisy image for the denoised image we just created. So now if we hook up this baked image to the material output, it should look the same as our mix shader, except now it has been rendered and baked into this image. And now we can finally do the delighting step. I've rearranged these windows just a bit. Now to start, I'm going to take this connection away so we can better see what's going on. Then I'm going to remove this shader input from the color mix node and replace it with our baked image. Make sure this factor is set all the way to 1, and then if we Control Shift and click this to make it the output, we see our delit footage. Now I'll make a little bit more space and we can duplicate this diffuse shader and use this mix node as the color input here. And if I now view this node, our rendered view looks exactly like the footage. And now when we turn our VFX elements back on, they just work right in the viewport. And now that we've set up everything the hard way, let's never do that again, and let's just use Ian's Compify plugin to make everything a lot easier. So let's rewind back to the beginning. To start, let's go to the Scene Properties tab where we'll find the Compify dropdown. First, we'll open the file for our footage here, and then we'll select the object that represents our camera here. Then you'll want to hit these 2 buttons here, which will create 2 collections, one for the footage geometry and one for the footage lighting. The footage geo collection should contain all the objects that line up with your footage, which I've already done. And the footage lights collection should have all the lights or objects that recreate the footage lighting. So let's say we created a sun object to help recreate the lighting. We'd put that in this footage lights collection. But in this scene, all our lighting is being taken care of by the world shader, HDRI. So we'll just leave this collection empty. Now with all this set up, we can go ahead and hit the button Prep Scene. But first, I want to select this object and change over to the Object Shader Editor to show you what this button is doing. So now let's hit the button. This will look at all the objects in this footage geo collection and make a new Compify material, which includes this node for the footage. And since I'm using an image sequence, I have to make sure I set the correct values for these settings, and then let's Control Shift and click this node to see our footage. And as we can see, Compify has automatically set this up to project properly onto this geometry. Another thing that happened when we hit Prep Scene, we'll notice that every object in this collection has a new Compify UV map created, which is to prepare these objects for the baking process. We can see this Compify UV map being used over here, and this image texture node is where the baked image data will be stored. We can set the resolution of the baked image with this setting here, and this bake margin setting is the same setting that we have in the main bake menu, which we'll leave at 4 pixels. Let's reconnect this Compify node to the material output, and now we can hit Bake Footage Lighting. This will automatically switch this material to the white material and bake this image. We don't have to worry about selecting the right objects or hiding extra objects in our scene. Compify is only going to use the objects in the Footage Geo and Footage Lights collections along with the World Shader to do the baking. And after the baking is finished, Compify automatically switches over to the proper delit footage material. Finally, we should save out this baked image by going into the image editor, finding the image, and then going to Image and Save As, and save this as an EXR file. And then really all that's left to do is add in our VFX elements. To wrap things up, let's talk about rendering and compositing. There are a few different approaches we can take. One approach is to simply leave everything as is and render everything together, which is what I did for this shot. Now currently, we've only baked the lighting on this frame, and that bake will be used for all the other frames throughout the shot. But this can cause issues if the camera moves a lot, like this weird shift in lighting you can see here. To solve this, Compify has this button, Render Animation with Compify Integration, which will render the scene and rebake the lighting on every frame. This can lead to more stable results. Also, as I mentioned earlier, you might want to break the scene into multiple render passes to give you more control over the final image. But this video is getting a bit long, so I've created a separate, more informal video that goes over all the rendering and compositing. You'll find that video at the same link as the tutorial files below. Now, delighting is not a perfect technique for every VFX shot. It works best in scenes with flat, even lighting and with rough surfaces like concrete or dirt. And as you explore delighting yourself, you'll get a better understanding of these different limitations. But going forward, I think I'll always at least try to delight every VFX shot, because when it does work, it just feels like magic.
When you want it looking right.